everyone, welcome back to the channel. I'm the GCSE science teacher, and in today's video we're going to continue with electricity. This is part of GCSE Physics. The topic itself is power and energy transfer. So if you do enjoy the video, feel free to subscribe, like the video and share it with someone else you think would benefit from learning more. Let's get into it. So you need to first of all understand what power is. Power is the energy transferred per second. So it's very much linked to energy. Energy, as we know, is the ability to do work. So if we were to put power into an equation, we would say that power is equal to the work done over time, okay? Energy that's transferred per second. Remember that energy is measured in joules, but power itself is actually measured in watts. And you can see that there are two equations that you need to recall, but also apply at GCSE, and they are as follows. So we have power is equal to the potential difference times the current, and power is also equal to the resistance times the current squared. And as you can see, power, like I mentioned, is measured in watts, current is measured in amps, voltage or potential difference is measured in volts, and resistance is measured in ohms. I have put these into a triangle equation for you, so it's a bit easier to rearrange, but be very aware that current in the second case is squared, so you would need to square root it if you want to work out the actual current in a question, for example. So here are some example questions for you. The first one says, how much energy is transferred each second by a current of 3 amps driven by a potential difference of 230 volts? So the first thing you want to do with any question like this is write out the equation. P, which is power, is equal to the voltage times the current. We know the voltage is 230 in the question, and we're timesing it by 3 for the current. So if we calculate that, we would get an answer of 690 watts. Remember, anything you type into your calculator, you need to write down as well. Here is a question for yourself. So how much energy is transferred each second by a current of 5 amps driven by a potential difference of 140 volts? Comment down below, what do you think the answer is? I'll leave the answer in the description box for you. Okay, so devices and energy transfer. Now, we know as everyday devices that we see, sometimes they are more efficient than others. In fact, if you have heard in the news, especially recently in the UK, if you're from here, you'll know that the energy prices have gone up and a lot of people are looking for more efficient devices to use in their home. You may have heard about the air fryer. You may have heard about how much more efficient that is than a general technical oven. These are the sorts of things that are going on in the news right now as I film this. But there is some logic to that. So essentially, devices in the home will actually transfer energy from one store to another, whether that's a chemical energy into kinetic energy, or whether that's a electrical energy into a thermal energy. Remember, we can't create or destroy energy. We can only transfer it from one store to another. However, some appliances are actually very inefficient. They will actually release energy in a wasted form, in a wasted store. So, for example, some appliances like a light bulb, the main job of a light bulb is to turn on and emit light, but some light bulbs get really hot and emit heat and thermal energy, which is wasted energy. So these are the sorts of things that people have done over time to actually correct and make these devices more efficient as well. So let's have a look at the second equation and how this relates to the GCSE course. Well, the first question is asking us, it says, you turn on a toaster for 45 seconds. The toaster uses 700 joules of electricity. Calculate the power of the toaster. So the longer you leave a device on for, the more energy that it's releasing. And this is why these sorts of questions get asked, and they link to efficiency as well. So the equation that you'd need to calculate this answer would be power is equal to energy divided by time. Okay, so power, we know, is going to be equal to energy divided by time. So the energy we have is 700 joules divided by time, which is 45 seconds, and we get an answer of 15.6 watts. Remember that time is going to be measured in seconds in this case. One of the ways they could catch you out is by giving you the information in minutes or hours. You would then need to convert it. Be very mindful of that. If they are looking for those sorts of steps, it's going to be worth more marks. Again, there's a question for you to have a go at. I'll leave the answer in the description box below. Comment down below, what do you think the answer is to this question? So again, at GCSE, they like to give you lots of questions that are to do with different equations. This is another equation that you could get asked about for energy transfers and power. So it says how much energy is transferred when 3 coulombs of charge moves through a potential difference of 12 volts in an electric toy car. So you need to know the equation. Energy transferred is equal to coulombs, or the charge, which is Q, times by the potential difference in volts. So when you write that out, E equals Q times V, you would put in the numbers. Okay, so 3 is the number of coulombs of charge, times by 12, which is the voltage, and you would get an answer of 36 joules. And again, there is another question for you to have a go at and practice your skills. Don't forget to include your units, write out the equation first, and substitute those numbers in. Okay, so if you get asked in the exam about power ratings and devices and what these numbers mean, I have seen this in the exam, but it's one of those things that may only be worth a few marks, but it's something to be aware of, because when you do sit the exam, they could ask you something like this. So we've got a kettle here, and if you look on any electrical device, you'll actually see these. If you go into your home, you'll see this actually on there. And essentially, it's like a label, and it tells you some information on it. So what this label means, it just tells you in the UK, for example, the potential difference you need for a device to work is 230 volts. That's actually a number you need to be aware of for your GCSEs. The frequency of the device, you can see in this case, is 50 hertz. Frequency is measured in hertz. And also, where you see 2000 watts, you can see that that tells you the amount of energy supplied per second from one store to another. So in this case, the kettle actually transfers 2000 joules of energy per second, which is obviously quite a high amount of energy. So that's just what those numbers mean. Sometimes they will ask you to look at a device and ask you what those numbers mean. Remember, the best way to distinguish this is to know the units. Hertz is the frequency of the supply, of the power supply. You also know that the volts is the potential difference, and 230 is what is needed for all devices in the UK, which is what you'll be asked about. Thank you so much for your time today. I've been the GCSE science teacher, and you have been curious. If you did enjoy the video, feel free to like it, share it with someone else, and subscribe. It's always great to have you here as part of our community. So thank you if you already have subscribed. Share my channel with your friends and anyone else you think would benefit from being part of this community. And until next time, I hope you have a great day. Take care. Bye.